What's up there guys, thanks for tuning in. I'm Rick, this is Fan for the Conscious, and in the video today we're going to be talking all about light and the wave-particle duality. Let's dive in. So I'd like to give you a warm welcome to Left Brain Spirituality Part 3, and this part is called Let There Be Light. So first thing we're going to ask is, what is light? Well, light is defined as electromagnetic radiation. Electro meaning electricity, magnetic meaning magnetism, and radiation meaning the emission or propagation of energy or matter. So before we go any further, we've got to first sort of understand the relationship between electricity and magnetism. Now, they are not actually two separate phenomena. Electricity and magnetism are intrinsically linked and are two opposite sides of the same interaction. So wherever there is electricity which is moving, wherever there is the movement of charge from one place to another via the flow of electricity, there is necessarily a magnetic field created. So moving electricity creates a magnetic field around the medium through which that electricity is travelling, and a moving magnet creates flowing electricity. This is how the principle of generators work. You have a magnet which is spinning round within a copper coil, and that moving magnetic field generates an electric current. By the same token, when you do have electricity flowing through a wire, you get a magnetic field which is generated around that. So the two are intrinsically linked, and wherever you have magnetism, you have electricity. Light itself, this electromagnetic radiation, is an oscillation, a wave, a vibration of electricity and magnetism in tandem. Now you'll often see waves drawn in this, call it a transverse manner. Imagine like the waves on an ocean. We'll get into that a little bit later. But what is actually happening is the electric vibration and the magnetic vibration are happening in two independent planes. They are happening perpendicular to each other, and you encounter this with the left hand and right hand rules. I'm not going to go into that in any detail, but any of you who are a little bit more into their physics will know the left hand rule, whereby the direction of the flow of current generates a magnetic field which generates movement in a given direction. And you can see this in the deflection of a wire when it's placed within a magnetic field and current is run through it. So we've got these three different dimensionalities to the electromagnetic wave. You've got the dimensionality of vibration of the electric current, and you've got the dimensionality of the vibration of the magnetic current, and then you've got the direction in which that electromagnetic radiation is moving. So it's a three-dimensional structure, not flat as I've drawn on the board here. And it's important to bear that in mind as we move forward, and you will find an awful lot with many of the things we'll be covering in Left Brain Spirituality, that in each given module, you might call it, or episode, that it's very important to bear in mind the previous information that we have discussed in other videos. So when we're considering this idea of light, I want you to be very cognizant of the importance of energy and light and mass and how they all interact via that wonderful equation E equals mc squared. And we can see that the light is a fundamental function of both energy and matter in itself. So that's the basic idea. It's got an electric current and a magnetic current which are oscillating perpendicular to each other and moving in a given direction, and that gives you the idea of what light itself is. And it exhibits both wave and particle behaviour, and this is the wave-particle duality, which we will cover in the second half of the video. So what is a wave? Well, a wave is an oscillation of a medium, and this is an important distinction to make, an oscillation of a medium. On the other hand, a particle itself is a single quanta of a substance, a single packet which is considered to be indivisible. So light is an oscillation of a medium when considered as a wave. What is this medium? Is this medium space itself? Is space itself an electromagnetic soup which is vibrating very much like the waves in an ocean? So the ocean is creating the waves. So is space creating the light by vibrating at a certain frequency to produce that? And this is all the sort of thing that we're starting to cover today. So what is light? Again, we're talking about the spectrum of electromagnetic radiation. And that moves from gamma rays up at the top end here, which are the highest energy electromagnetic rays or electromagnetic photons. And then they move all the way down and increase in wavelength. So the length of that wave, again, if you're imagining an ocean, the length of that wave gets larger and larger as the energy itself decreases. So it's this continual spectrum of different frequencies, different wavelengths, and different energies. The higher the frequency, the shorter the wavelength, the higher the energy. The longer the wavelength, the lower the frequency, the lower the energy. So the highest energy electromagnetic radiation is gamma rays, and then you move through X-rays, soft X-rays, extreme ultraviolet into visible light, and this is a very, very small section of the electromagnetic spectrum, the bit we actually see and the bit we traditionally think of as light. Then we move into the infrared part of the spectrum, which is what we sense as heat. And then we go into microwaves and radio waves. And this is the sort of the largest portion of the spectrum as we know it. Now, here is a very, very interesting point, because what they did is, as part of a black body radiation emission experiment, I believe that's exactly what it was called, there was a discovery known as the Ultraviolet Catastrophe. And what the Ultraviolet Catastrophe discovered was that the electromagnetic spectrum is functionally infinite. The scientist involved tried to figure out what is the maximum amount of energy that could be emitted from a perfect black body sphere, so one that perfectly absorbed any radiation that came into it and also emitted that as radiative heat. Again, heat, radiation, is only one part of this infrared spectrum. Black bodies with energy would emit light across the whole range of the spectrum. And the problem we had is that when we tried to figure out what the smallest possible wavelength was, we discovered there wasn't one. There was no actual smallest wavelength and probably no actual longest wavelength. So this electromagnetic spectrum, and that's why I've drawn little arrows on the end of each of these, extends beyond what we can measure into the infinite in either direction. And the problem that we have with that is that means there is effectively an infinite amount of radiation that could be radiated from a perfect black body. Now, mathematicians don't like putting infinities into equations, because when you put an infinity into an equation, that equation tends to become pretty useless as it starts to spit out infinities. And infinities aren't very, very useful for trying to do calculations. You end up with ridiculously large or ridiculously small numbers, infinitely so, in fact. And that is why they called it the ultraviolet catastrophe, because taking into account the infinite nature of the electromagnetic spectrum, there is effectively an infinite amount of energy available within it. So this brings us now over to our wave-particle duality. And the wave-particle duality came off the back of the UV catastrophe, and they resolved the ultraviolet catastrophe by normalizing the numbers. What does normalizing mean? Well, they defined the electromagnetic spectrum as having a lower limit, a smallest possible wavelength that could be produced. Despite the fact that the experimental evidence seemed to indicate the infinite nature of the electromagnetic spectrum. So they define the smallest possible quanta of the electromagnetic spectrum as a Planck wavelength. So that is the smallest possible wavelength that can exist, and a Planck is considered to be the smallest possible measurement of anything. It's more appropriate to think about a Planck as the smallest possible visible pixel, and I use the term visible pixel because in theory you can infinitely divide these up into smaller and smaller wavelengths. However, there is a limit to the ability of a being that exists at this scale of the universe. It's a limit to our ability to perceive things at very small scales. And again, also a limit to our ability to perceive the longest possible wavelengths on the scale. So this produced the idea of a photon, which is a single packet of light. You can think of it as a particle of light. Now, in theory, again, you could define an upper limit to the increasing wavelength of light. And I suppose in theory, that would be a wavelength which is the entire size of the universe. Now, that isn't to say that there are not wavelengths bigger than that, but there becomes practical issues with measuring and receiving and recording those wavelengths. For one, due to the time it takes for a single oscillation to happen. At the top here we've got 3 Hertz, which is 3 cycles, 3 oscillations, 3 waves per second. And that can actually be counted. You know, you've got a third of a second. You could probably actually count that using your own brain and your own perception. What if it was 1 oscillation every 24 hours? What if it was 1 oscillation every 60 days? What if it was 1 oscillation every 1,000 years? How easy would it be to measure those kind of wavelengths? How easy would it be to even notice the change in a wavelength, the change in an emission over that length of time? So what we're dealing with here is not necessarily limits of the universe, but limits of man's ability to perceive the universe. Going back to the whole idea of wave-particle duality, the UV catastrophe was resolved by normalizing the lower limits of the electromagnetic spectrum to the smallest possible quanta of 1 Planck wavelength. That produced the idea of a photon, a given physical, measurable, self-contained packet of light. However, the double slit experiment experimentally proved that light can also behave as a wave. And more interestingly in itself, is also the double slit experiment been performed with molecules. So we're not just talking about single photons of light, we are talking about molecules of matter made of tens and sometimes even hundreds of atoms has been seen behaving in a wave-like manner and not in a particulate manner. Very, very interesting. So we're starting to see now, and if you haven't seen my previous video, Left Brain Spirituality Part 2, I do suggest that you head up to the link that I'm going to put above right now or at the end of the video and check that out, because we're starting to get to the idea now of how a wave can be seen to behave like a particle. So, we've talked a lot about waves. Let's discuss them in a little bit more detail. And this here is where you might start to see some similarities between what I've been discussing today and what I mentioned in my previous video, What is the Matter? So waves come in 2 forms, and you can think of them either as transverse waves or as longitudinal waves. Now, a transverse wave is where the oscillation of the medium, the movement of the medium, happens perpendicular to the direction of travel. Wave is traveling in that direction, medium oscillates up and down. Think of a wave on the ocean. A wave moves in a given direction, but it also oscillates in a perpendicular direction. In the idea of longitudinal waves, the oscillation of the medium happens in the same direction that the movement happens. So rather than having this up and down flowing water-like wave, you've got alternating compression and expansion, compression, expansion, compression, expansion, compression, expansion. That is a longitudinal wave, and this is best thought of in terms of sound waves, because now you're looking at a three-dimensional propagation of that wave. So that's two ways of considering how a wave functions. Here is another way of looking at a wave, but from the perspective of a particle. If you have a particle moving through a medium and that particle is rotating, it is spinning, if you were to take one point on that particle, imagine this ball that's spinning around as it's moving. If you follow that single point on the particle as it moves, it will generate a waveform behind it. So now we can see the idea of particles producing waves and waves being visible as particles. Now what we're actually talking about here, they're the same thing. We're just looking at two different ways of perceiving it. And that perception is dependent on the circumstances in which you're choosing to measure it. You could find a ship on the ocean by looking for the ship, but you could also find a ship on the ocean by following its wake. Now imagine that instead of there actually being a ship on the ocean, there was a wave which was moving in such a manner that it appeared to be a particle. Now we're going to sort of bring it full circle and talk about how we can have this oscillation in three dimensions. The closest thing we can get to imagining a particle as a function of a medium, so the medium creating the illusion of the particle, is thinking about water. And if we think about the idea of a vortex in water or a vortex in air. In a vortex, you are having different levels of density of those particles. And if you were to take this spiral, this vortex whirlpool, and you flip it on its side now, so here's the top of the water and here's underneath the water, what you get is this dip, which looks very much like the dip on a waveform. So we're getting the structure of a waveform now out of a vortex pattern. And what happens to a vortex pattern when you take it off a two-dimensional surface, the surface of water, and you create it in 3 dimensions, you get something called a torus. And a torus is like a donut shape. Imagine taking a sphere and pulling the north and south pole in so that they meet in the very center of that sphere. What you will get now is a torus shape, and that is a 3-dimensional vortex. Now, if you want to get an idea of how a 3-dimensional vortex could be perceived to be a ball or a sphere or a particle, go out and get yourself an air Zuka. If you've never experienced one of these before, you can actually make them yourselves out of a yogurt pot and a balloon, or a Pringles can and a balloon. Go and check out on YouTube, have a look at how to make those, and try firing a little vortex of air at somebody else. Try firing it at yourself, and you'll notice that it actually feels very much like you're being hit by a ball of air. What you're actually getting hit by is a torus, a 3-dimensional spinning vortex of air. Now imagine taking this 3-dimensional vortex, turning it sideways and propelling it through the air. What you are getting is a form of longitudinal wave. So maybe what we think of as particles are actually little vortices of the ether or space itself, the electromagnetic fabric of which we are all a part, moulding itself into a shape that we could perceive as matter. If you have enjoyed this content, please don't forget to subscribe, hit the thumbs up and the notification bell set to all. We'll make sure you are always kept up to date with all my latest content, which drops on a Monday and a Wednesday and a Friday at 8 PM UK time. If you do want to join me over at lawfulbank.com and be part of our lawful people's gatherings, assemblies and conventions of your nations, then please go and sign up, get yourself an account and start talking to me on the forums. Take care of yourselves, guys. Don't forget to stay free, think free and act free. I'll see you next time.